So next we will start with inverse of a matrix. Now what is inverse of a matrix? Suppose I have a matrix A which is a square matrix and which is a non-zero square matrix. So there are two primary conditions for inverse of a matrix to exist. First condition is it exists only for square matrices. Second, the matrix has to be non-zero. In other words, it has to be non-singular matrix. So these are the conditions for an inverse of a matrix to exist. So if A is a matrix, we say its inverse exists such that I can find a matrix B such that the product AB is equal to BA is equal to identity. The order of identity matrix will be same as the order of matrix A. Then we say A is invertible and its inverse, which we write as A inverse, is equal to B. So we say A is invertible. If its inverse exists, then A is invertible. So next we have a result. We will find the inverse of a matrix by three methods. Everybody has to remember this very clearly. We will find inverse by three methods. First by formula. Second is in the question, sometimes equation. Most of the time equation. And third is elementary operations. Elementary operations. So first is by formula. So we'll derive a formula. We have done this particular result A into adjoint A into A is equal to determinant of A into identity. So I'll take one part. A into adjoint A is equal to determinant of A into identity over here. So now what I'll do, I'll just pre-multiply A with both the sides with A inverse. So then A inverse into A. Over here A is inverse of B. So most of the times it is written as A inverse into A into A inverse is equal to identity. So it is equal to identity. This is adjoint A and this is A inverse determinant of A into I, determinant of A being number. So this can come to this side, so it will be adjoint A upon determinant of A is equal to A inverse into I, which is A inverse identity multiply a matrix. If it is multiplied with any matrix, it gives us the same result. So what is A inverse? Adjoint A upon determinant of A. For this formula to exist, this should be non-zero. So hence we said earlier also, inverse of a matrix exists only when we have a non-singular matrix. So hence by this formula we can find the inverse of a matrix. This formula we will use almost all the times unless until it is specified in the question that we have to do by a particular method. For example, how do we find inverse by equation? In most of the questions that we have done in matrices also, we were supposed to verify a particular equation. Let's say this particular equation to be equal to 0 for a given matrix A. Any square matrix was given and we had to verify a particular equation. Then the question further asks us to find the inverse of a matrix using this particular equation. Then if it is given in the question that we have to use the equation, we cannot apply any other method. Remember clearly, you have to read the instructions given in the question. So what we will do in this case, we will pre-multiply by A inverse like this. So this will be like this. So over here A inverse, if we say the powers, this will be A and these two will be identity. This will be A inverse is equal to 0. Identity multiplied with any matrix will give me the same matrix. So I can write it as 7A inverse 5I minus A. So A inverse will be equal to 1 upon 7 5I minus A. So this is the second method where the equations are given. We have to use those equations and find the A inverse. We'll put the value of I given in the question and find the A inverse. Third method is elementary operations. Elementary operations are of two types: elementary row operations, elementary column operations, which we will be discussing in detail. First of all, let's focus on the formula and the equation type of questions. Today we will discuss about some important results of inverse as well as of the adjoint. Now what is this result? It is very often used in some of the questions, 6-marker question. What it says, A transpose inverse is equal to A inverse transpose. Although the proof will not come in exam, but we have to remember the results for doing certain questions. Okay, so what we know it is given in the proof or the statement that A is invertible, and then you have to prove that A transpose is invertible, as well as A transpose inverse is equal to this. So if I know A is invertible, it means determinant of A is non-zero. We know that the determinant of A transpose as well as the determinant of A are equal. So if this is non-zero, it means this is also non-zero. So it means A transpose is invertible. This we know. A transpose is invertible. Now, I know since A is invertible, so A into A inverse is equal to identity is equal to A inverse into A. When a matrix is invertible, it means A inverse into A is equal to identity. So I'll start from this particular thing. I'll write A into A inverse is equal to identity. Now what we will do, we will take transpose of both the sides. I can do it for both the results. So I'll take the transpose of all the three. So transpose, so over here it is this transpose. Now what do we know? AB whole transpose is equal to B transpose A transpose. Transpose of identity will be identity only. Over here also A transpose A inverse transpose, because we know that AB whole transpose is equal to B transpose A transpose. This is the result that we know. So based on that, now what do I observe? The product of these two is equal to identity. So when product of two matrix is equal to identity, over here also the same matrix are there. So what we can say, the inverse of A transpose. The inverse of A transpose is equal to A inverse transpose. This is my one matrix, this is my second matrix. If the product of both is equal to identity, they are inverse of each other. So I can say inverse of this is this. The same thing applies to the other. Now the next result is adjoint AB is equal to adjoint B into adjoint A. The same result as we have for transpose, the same result we have for inverse, and the same result we have for adjoint. The terms are interchangeably multiplied. So what do we know? We know A and B are non-singular matrices. So A is non-singular, it means it is non-zero, and B is non-singular means it is non-zero. So I know AB is equal to determinant of A, determinant of B. If both are non-zero, it means determinant of AB is also non-zero. So it means AB inverse exists. So we know this particular thing when the determinant is non-zero. Now I know since A is non-singular, so inverse of A will be adjoint A upon determinant of A. Similarly, B is non-singular, so I can write the inverse of B as adjoint of B upon determinant of B. Now since we have to prove, and AB inverse can be written as adjoint of AB upon determinant of AB. Now I will start from adjoint of AB. Adjoint of AB, I will multiply and divide it by the determinant of AB. I will multiply and divide it by determinant of AB. Now what do we know? In place of this, I can write it as determinant of AB can be written as determinant of A, determinant of B, and this can be written as AB inverse. So this is inverse of AB. Now what do we know? AB whole inverse is what? B inverse, A inverse. So in place of B inverse and A inverse, what can I write? This is determinant of A, this is determinant of B. In place of B inverse, I can write adjoint B upon determinant of B. In place of this, I can write adjoint A upon determinant of A. We can cancel these two, and hence the result adjoint AB is equal to adjoint B into adjoint A. So these results as such proofs are not asked in exams, but these results we use for solving some of the questions. So we have to keep these two results in mind. Next we will move on to exercise 4.5. I have already discussed question number 1 and 2 in the adjoint video, and question number 3 will be done on the same line, so everybody will do. I'll do question number 5, a 2 by 2 matrix for finding the inverse and a 3x3 matrix, that is question number 11, how we will find the inverse. The rest of the questions everybody will try as homework. So now what do we have? Question number 5 is, we have a 2x2 matrix. The question says you have to find the inverse if it exists. So you have to read each and everything, and the pattern that I tell you, you have to follow the same pattern in exam, because marks are for following the steps. We will not be doing shortcut methods here. Shortcut methods are only you will be using them only when you have an MCQ question, so that you can quickly, or if you want to verify your answers, then only you will be using the shortcut method. For CBSE board exams, you will be following a specific pattern, which is this particular pattern. Everybody will follow this pattern. Okay, right? So what we will do, we have a 2x2 determinant. The question says if inverse exists. So how do we know inverse exists or not? First thing that we have to do is, first step, everybody will find the determinant. So for 2x2, how do we find the determinant? We cross multiply and find the determinant. So 3 into 2 is 6 minus 2 into 4. So what will I get? 6 plus 8, that is 14, which is non-zero. Hence, A inverse exists. So everybody will write, hence A inverse exists. So first thing everybody will do is finding the determinant, whether it is a 2x2 matrix, whether it is a 3x3 matrix. So first thing we'll find the determinant. If it is 0, we will say inverse does not exist. If it is non-zero, we will say inverse exists. Next thing is to find the cofactors. We will be doing these two questions, all the questions unless until specified by the formula, which is A inverse adjoint A upon determinant. So to apply this formula, I need determinant and I need to find the adjoint. For finding the adjoint, what do I need? I need to find the cofactors. So first thing, you will write it like this: A1, A12, A21, A22, and you will put the signs first of all at the places. These two odd places, you will put the signs so that you don't do any error. Now, A11, I will cover it like this. So it is 3, A1. So A12 will be 4 if I cover it like this, and A21 will be minus 2. Minus is already there, so plus 2, and similarly this particular thing. So we have discussed this in detail. Now cofactor matrix, I will write it like this. Try writing it like this. It will help you and you will not have many errors in the question, and you will avoid errors this way. So what is adjoint? Adjoint is transpose of this particular cofactor matrix. So I will change rows to column, columns to rows. So I have written it in the form of adjoint. Now what is A inverse? A inverse is determinant. Determinant is 1 by 14. We will always keep that particular factor outside the matrix sign. No need of taking it inside. Always, everybody will keep this particular thing like this, and this is the proper presentation for board exams. This is how everybody has to present. Now for 3x3, what I'll do? First thing that I'll do is I'll find the determinant. So since we have zeros along first row and first column, so I can expand it along first row. So it is, if I cross multiply, what will I get? Minus cos square alpha minus sine square alpha. So if I take minus common, it will be minus 1. Sine square theta plus cos square theta is 1. So determinant is minus 1. Non-zero, it means A inverse exists. So we will say A inverse exists. Next, what we have to do is we have to find the cofactors. So first thing that I will do for finding the cofactor is I will quickly put the signs at the 4 places. So everybody, first step, everybody will do it like this only. You will quickly put the signs at 4 places, and then we will cover it along rows and column. For first, I will cover it along row and column. Cross multiply, what you will get? You will get it as minus 1 minus cos square alpha minus sine square alpha minus common. So answer will be minus 1 over here. Next, A12, we will cover it along row and column. We will cover it along row and column. So 0, 0. So answer is 0 over here. So minus will not make any sense. Next, I will cover it like this, 0, 0. So again, this is 0. A21, we will cover it like this. We will cover it like this particular thing. So again, this into this, 0. So this is also 0. A22, we will cover it like this. We will cover it like this and this. So minus cos alpha. So we will write it like this, minus cos alpha. A23, I will cover it like this and this. So it is sine alpha. So minus is already there. So it is sine alpha. Next, A31, I will cover it like this, 0, 0. So it will be 0 over here. Then if I cover it like this is sine alpha, minus sign is already there. A32, I'll cover it like this, so it is cos alpha. So we have got our cofactors. Now I'll put it in the form of matrix. So all the cofactors will go in the form of a matrix like this. Let's quickly put it up. So this is minus 1, 0, 0, 0 minus cos alpha minus sine alpha, 0 minus sine alpha and cos alpha. Now adjoint is what? Adjoint is the transpose of this particular matrix. So I will write the transpose as minus 1, 0, 0. This will be 0. This is minus cos alpha minus sine alpha. This is 0 minus sine alpha cos alpha. I'll write column as rows, so it will change. Now what is A inverse? A inverse is adjoint upon determinant. So determinant is minus 1. I'll write it there only. Minus 1, 0, 0, 0 minus cos alpha minus sine alpha, 0 minus sine alpha cos alpha. So this is my A inverse for a 3 by 3 matrix.